Hello everyone, welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. In this lecture, tutorial number 16, we are going to simulate and analyze the rock slope using Hoek-Brown model in PLAXIS 2D. The model geometry is like this figure. It will be this figure, as you can see. We have irregular rock slope geometry, and we have drawn this slope geometry using AutoCAD, and we will import this geometry to PLAXIS 2D, and we will run the analysis and see the factor of safety and failure surface for rock slope. So in this lecture, we will learn how to use a Hoek-Brown model for simulation of rock, and also we will import slope geometry from AutoCAD DXF file to PLAXIS 2D, and we will shortly talk about the parameters of Hoek-Brown constitutive models in PLAXIS 2D and how can we estimate some parameters from some charts from Geotechnical textbooks. Also, as usual, we will see the safety factor and failure surface of the slope. So, parameters of the main parameters of Hoek-Brown model is uniaxial compressive strength and material constant M sub I, geological strength index GSI, and also disturbance factor D, and stiffness parameters elasticity and Poisson ratio. So the uniaxial compressive strength of intact rock, it's denoted by sigma sub Ci, or sometimes denoted by sigma sub C, Q sub C, or UCS, which is identification of unconfined compressive strength. So this is the maximum axial compressive stress that a rock sample can withstand before a failure. So this parameter can be found in a laboratory using there are many standards, and these standards can be used as STEM-D 7012, or sometimes if we don't have any laboratory data, we can assume this value from some charts or tables from geotechnical or geological textbooks. Also, we have another parameters. It's called material constants, and it's denoted by M sub I. These parameters derived from the properties of the intact rock and degree of fracturing, and so it means it depends on the intact rock and how this rock is fractured and the degree of fracturing. This can be estimated from published tables based on rock type in many geological books. Also, we have a geological strength index. This is also a parameter that reflects the condition of the rock mass in terms of blockness and surface condition. Actually, this is this parameter GSI can be found by visual field assessment using rock mass blockness and joint condition charts. And we have a disturbance factor. Actually, this disturbance factor is mostly used in when the tunnel simulation. It's a factor that accounts for the degree of disturbance or damage to the rock mass, and it is chosen from guidelines depending on excavation method and quality of blasting and tunneling. And actually, these materials and charts are available in PLAXIS 2D material dataset. So we will see when we define the material properties for Hoek-Brown model, we can see the ranges for each of these parameters for different types of rock. Also, we have these are the stiffness parameters can be found in the laboratory or from published tables in geological or geotechnical textbooks. So the calculation is finished now. We can check the results again in here. So as you can see, this is a critical failure surface of the slope. Right now we can see the complete failure surface for the slope. So that's why it's important to use the enough boundary condition. Actually, it will be better if we extend from the left more geometry. It will be better. So it's okay for now, and the purpose is to use the Hoek-Brown model in PLAXIS 2D. And this was for this lecture. I hope it was clear and useful. Thank you for watching. See you in the next tutorial.